Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. Today we will study about the thermal properties of matter. One shot lecture part 2. One shot part 2. I divide this video into two parts because first part becomes lengthening, and that's why I divide this one short lecture in two parts. In first part we studied about the thermometry, means study of temperature and related to all its concept, that is thermometry, and today we have to study about the calorimetry. What is the calorimetry? Calorimetry. A branch of science which deals with the study of heat and its measurement, that is called as calorimetry, and with the help of calorimeter we can measure the heat. Okay, now to study the calorimetry concept, first we have to study a concept of specific heat capacity. Specific heat capacity. Specific heat capacity, or simply we can say that specific heat. Now for that purpose we have to consider a unit mass of solid or liquid. Unit mass of solid or liquid. Now we have to increase the temperature of the solid or liquid by 1 degree Celsius. Now we know that temperature in degree Kelvin, that is nothing but temperature in degree Celsius plus 273, means when we have to increase temperature by 1 degree Celsius, naturally it goes on increasing by 1 degree Kelvin, because for example the temperature is 25 degree. This T, that is equal to 27 degree Celsius, and if we add 273 it becomes 300 degree Kelvin. Now we have to increase that temperature by 1 degree, means we have to increase from 27 degree Celsius to 28 degree Celsius. Then 28 plus 273, it becomes 301 degree Kelvin. Means when you increase the temperature by 1 degree Celsius, naturally 1 degree Kelvin is rising there, because 300 degree Kelvin it converted into 301. Means if we increase the temperature by 1 degree Celsius, it automatically increase in 1 degree Kelvin. And to increase the temperature of the solid, unit mass of solid or liquid by 1 degree Celsius or 1 degree Kelvin, we have to supply heat. Suppose Q is the heat supply to that unit mass of solid or liquid. If we decrease the temperature by 1 degree, at that time we have to remove heat from that unit mass of solid and liquid, and that heat, that is called as a specific heat capacity. Understood? And we have to define the specific heat capacity. Specific heat capacity of a solid or liquid is defined as amount of heat or quantity of heat required to rise or fall the temperature of unit mass of a solid through 1 degree Celsius or 1 degree Kelvin. म्हणजे एखाद्या युनिट मास ऑफ सॉलिड किंवा लिक्विडचं टेम्परेचर 1 डिग्री सेल्सिअसने किंवा 1 डिग्री केल्व्हिनने वाढवण्याकरता किंवा कमी करण्याकरता जी हीट उपयोगात येते त्याला म्हणायचं स्पेसिफिक हीट कपॅसिटी. आणि आता याच्याहून मोलर हीट कपॅसिटी ऑफ solid or liquid. Instead of unit mass, you have to consider 1 mole. मग आता बघा, जेव्हा एक मोल सॉलिड किंवा लिक्विड हा त्याचं टेम्परेचर 1 डिग्री सेल्सिअसने किंवा 1 डिग्री केल्व्हिनने वाढवण्याकरता किंवा कमी करण्याकरता जी हीट आपण सप्लाय करतो त्या हीटला म्हणायचं मोलर हीट कपॅसिटी in case of a solids and liquids. But in case of a solid and liquid, only one specific heat capacity is present, because when we supply heat, the expansion in solid and liquid that is negligible, it is not considerable. म्हणजे जेव्हा आपण सॉलिड किंवा लिक्विडला हीट देतो आणि त्याचं जे एक्सपान्शन होतं ते एक्सपान्शन हे निग्लिजिबल असतं, ते कन्सिडरेबल नसतं आणि म्हणून सॉलिड किंवा लिक्विडला जी स्पेसिफिक हीट असते ती एकच स्पेसिफिक हीट असते. मग ज्यावेळेस आपण गॅसला हीट देतो त्यावेळेस त्याच्यामध्ये एक होणारं एक्सपान्शन हे निग्लिजिबल नसतं, ते कन्सिडरेबल असतं आणि म्हणून आपण जेव्हा गॅसची स्पेसिफिक हीट कपॅसिटी शिकतो त्यावेळेस आपल्याला एकतर त्याचं प्रेशर कॉन्स्टंट ठेवावं लागतं नाहीतर त्याचा व्हॉल्यूम कॉन्स्टंट ठेवावा लागतो. म्हणून गॅसच्या बाबतीत 2 स्पेसिफिक हीट कपॅसिटी असतात आणि म्हणून आता आपल्याला शिकायचं आहे स्पेसिफिक हीट कपॅसिटी ऑफ ए गॅस. Specific heat capacity of a gas. Specific heat capacity of a gas. Consider a unit mass of gas. Unit mass of gas. And we have to increase its temperature through 1 degree Celsius or 1 degree Kelvin. For that purpose, we have to supply heat, and that heat that is called as a specific heat. Amount of heat required to rise or required to fall the temperature of unit mass of a gas through 1 degree Celsius or 1 degree Kelvin, that is called as specific heat capacity of a gas. Now it is divided into 2 parts. When we kept its pressure constant, at that time that heat is called as SP, specific heat of a gas at constant pressure. Then what is the definition of specific heat capacity of a gas at constant pressure? Specific heat capacity of a gas is defined as the amount of heat or quantity of heat required to rise or fall a temperature of unit mass of a gas through 1 degree Celsius or 1 degree Kelvin when its pressure is kept constant. Now we have to define the specific heat capacity at constant volume. Then only you have to change the condition. For that purpose, you have to keep volume constant. And therefore, the definition of specific heat capacity of a gas at constant volume is defined as amount of heat or quantity of heat required to raise the temperature of unit mass of a gas through 1 degree Celsius or 1 degree Kelvin when its volume is kept constant. And these 2 heats together, that is called as principal specific heat. Principal specific heat capacity or principal specific heat. Now we have to define molar specific heat, and it is denoted by the Cp and Cv. Molar specific heat at constant pressure and molar specific heat at constant volume. Only you have to change condition. Instead of unit mass, you have to consider the 1 mole of a gas. For molar heat capacity, you have to consider 1 mole of gas. 1 mole of gas. Then we have to define. Now this is the 1 mole of gas and we have to increase or decrease its temperature through 1 degree Celsius or 1 degree Kelvin, and amount of heat required for that is called and when its pressure is kept constant, it is called the molar specific heat capacity at constant pressure, and when its volume is kept constant, at that time it is called as the molar specific heat capacity at constant volume. Then we have to define molar heat capacity at constant pressure. It is defined as molar heat capacity is defined as amount of heat or quantity of heat required to raise or fall the temperature of 1 mole of a gas through 1 degree Celsius or 1 degree Kelvin when its pressure is kept constant. Understood? Now we have to define the specific molar specific heat capacity of a gas at constant volume. Then molar heat capacity at constant volume is defined as amount of heat or quantity of heat required to raise the temperature or fall the temperature of 1 mole of a gas through 1 degree Celsius or 1 degree Kelvin when its volume is kept constant. Now we have to study the relation between the principal specific heat and molar specific heat. Relation between principal specific heat and molar specific heat. Principal specific heat and molar specific heat. Molar specific heat. Molar specific heat. Now the molar, that is equal to the molecular weight into principal. This is the relation at constant pressure, and in similar manner the molar specific heat capacity at constant volume, that is equal to molecular weight into principal specific heat at constant volume, and this is the relation between the molar specific heat capacity and principal specific heat capacity. And formula for this specific heat capacity is that the S, that is equal to delta Q divided by M into delta T. Then this is nothing but heat required to rise the temperature through 1 degree Celsius per unit mass, per unit rise in temperature, and therefore this is the formula for specific heat capacity, and from this formula we can calculate its SI unit and CGS unit. Then what is the SI unit? The heat is measured in joule, mass is measured in kilogram, and temperature is measured in degree Celsius or joule per kilogram per degree Kelvin. This is the SI unit. Then what is the CGS unit? CGS unit of heat capacity, that is equal to erg per gram per degree Celsius or erg per gram per degree Kelvin, and that is the CGS unit of specific heat capacity. Now we have to study the heat equation. What is the heat equation? Heat equation. What is the heat equation? Now heat is supplied to the system. When we supply heat, then there is rise in temperature, and when we remove the heat, at that time there is fall in temperature, and therefore Q, that is when it is heat absorbed, we can write mass into specific heat capacity into rise in temperature. When heat is absorbed, that is equal to mass into specific heat, into rise in temperature. And when we remove heat, at that time heat lost, that is equal to mass into specific heat into fall in temperature. When we remove the heat, at that time heat is lost and there is a fall in temperature, and this equation that is called as a heat equation. Understood? And SI unit of this Q, that is joule or calorie. And we know the relation between joule and calorie, okay? And 1 calorie, that is equal to 4.184 joule, and that is nothing but approximately we can consider it 4.2 joule, and this is the relation between calorie and joule, and this is the heat equation. Now we have to study the concept, that is heat capacity. What is heat capacity? Heat capacity, that is also called as a thermal capacity. Thermal capacity. Thermal capacity or heat capacity. When we increase the temperature by 1 degree Celsius, at that time heat required for that is called as a heat capacity. Means when delta T, that is equal to 1 degree. Delta T, that is equal to 1 degree. At that time Q, that is equal to M into S, and this is called the heat capacity, or it is also called as thermal capacity. And what is the definition of thermal capacity or heat capacity? The amount of heat required to rise the temperature through 1 degree Celsius or 1 degree Kelvin, at that time that amount of heat, that is called as a thermal capacity or heat capacity. Now we know that the unit of mass, that is kilogram, and unit of specific heat, that is joule per kilogram per degree Celsius or per degree Kelvin. This kilogram that gets cancelled, and unit of heat capacity or thermal capacity, that is joule per degree Celsius or joule per degree Kelvin. That is nothing but joule into degree Celsius inverse or joule into Kelvin raised to inverse. In this manner, this is the concept of a thermal capacity or heat capacity. Now we have to study the most important concept, that is the latent heat. Latent heat. Latent heat. Latent heat. Latent heat. What is the latent heat? When we have to convert unit mass of, this is unit mass of solid, unit mass of solid, unit mass of solid, and we have to convert it unit mass of liquid, unit mass of liquid. At that time we have to supply the heat, okay? Heat is supplied to convert the change its state, and that heat that is supplied at its melting point, means solid gets converted into the liquid at its melting point. During that phase change, temperature remains constant. म्हणजे जेव्हा आपण एका कॅपिलरी मध्ये सॉलिड घेतो, मेल्टिंग पॉइंटचा एक्सपेरिमेंट करताना आपण एखाद्या कॅपिलरी मध्ये अगदी युनिट मास ऑफ सॉलिड घेतो, ती त्या याला बांधतो आणि त्याला हीट देतो. जेव्हा त्या ॲपरेटसला आपण हीट देतो, तर ज्यावेळेस सॉलिडचं लिक्विडमध्ये कन्व्हर्जन होतं त्यावेळेस त्याला आपण थर्मोमीटर बांधलेला असतो, आणि ड्युरिंग दॅट फेज चेंज टेम्परेचर रिमेन्स कॉन्स्टंट, अँड दॅट इज कॉल्ड ॲज लेटेंट हीट ऑफ फ्युजन. त्याला काय म्हणायचं? लेटेंट हीट ऑफ फ्युजन. मग आता व्हॉट इज द डेफिनेशन ऑफ लॅटेंट हीट ऑफ फ्युजन? दॅट इज डिनोटेड बाय a letter LF, latent heat of fusion. Latent heat of fusion is defined as the amount of heat or quantity of heat required to convert unit mass of solid into unit mass of liquid at its melting point without change in temperature. फेज चेंज होताना टेम्परेचर कॉन्स्टंट राहतं आणि हाच इथं महत्त्वाचा पॉईंट आहे. स्पेसिफिक हीट आपण जेव्हा देतो त्यावेळेस टेम्परेचर इन्क्रीज होतं किंवा टेम्परेचर डिक्रीज होतं आणि लॅटेंट हीट ज्यावेळेस आपण देतो त्यावेळेस तिथं टेम्परेचर कॉन्स्टंट राहतं. हा महत्त्वाचा फरक स्पेसिफिक हीट आणि लॅटेंट हीटमध्ये आहे. अंडरस्टूड. आणि म्हणून जेव्हा सॉलिडचं युनिट मास ऑफ सॉलिड हा युनिट मास ऑफ ए लिक्विडमध्ये आपण कन्व्हर्ट करतो आणि त्यावेळेस त्याचं टेम्परेचर जेव्हा कॉन्स्टंट राहतं तर त्या सप्लाय केलेल्या हीटला लॅटेंट हीट ऑफ फ्युजन असं म्हणायचं. परत एकदा मी रिपीट करते डेफिनेशन. दी लॅटेंट हीट ऑफ फ्युजन इज डिफाइन्ड ॲज दी अमाऊंट ऑफ हीट or quantity of heat required to change the unit mass of solid into unit mass of liquid at its melting point without change in temperature. And that is the definition of latent heat of fusion. आता जेव्हा आपण युनिट मास ऑफ लिक्विडचं युनिट मास ऑफ गॅसमध्ये किंवा व्हेपरमध्ये कन्व्हर्जन करतो त्यावेळेस सुद्धा आपल्याला हीट सप्लाय करावी लागते आणि त्यावेळेस सुद्धा जेव्हा ही फेज चेंज होते त्यावेळेस टेम्परेचर कॉन्स्टंट राहतं आणि त्यावेळेस सप्लाय केलेल्या हीटला आपण म्हणतो लॅटेंट हीट ऑफ व्हेपोरायझेशन. मीन्स कन्वर्जन ऑफ युनिट मास ऑफ लिक्विड इनटू वेपर ॲट इट्स बॉइलिंग पॉइंट अँड दॅट heat is called as the latent heat of vaporization. Okay. Then what is the definition of latent heat of vaporization? Latent heat of vaporization is amount of heat or quantity of heat required to convert unit mass of liquid into vapor at its boiling point without change in temperature. That is called as the latent heat of vaporization. Okay, I repeat both the definition once again. Latent heat of vaporization is latent heat of fusion is defined as the amount of heat or quantity of heat required to convert the unit mass of solid into unit mass of liquid at its melting point without change in temperature. And the latent heat of vaporization is defined as amount of heat or quantity of heat required to change the unit mass of liquid into vapor at its boiling point without change in temperature. Understood? Then what is the formula to calculate latent heat? Latent heat formula for latent heat, that is nothing but L, that is equal to Q by M. Okay. Now the SI unit of Q, that is joule, and mass, that is kilogram, and therefore SI unit of this latent heat, that is equal to joule per kilogram, and its CGS unit is the erg per gram. And this is all about the latent heat. Understood? Means what is the difference between specific heat and latent heat? Specific heat is used to increase the temperature. For that purpose, we have to study one graph, that is temperature versus heat graph. Temperature versus heat graph. Suppose temperature is, heat is here and temperature is here, temperature in degree Celsius is here. Now consider a temperature minus 20 degree Celsius and the water is in at ice form. Then we increase its temperature up to 0 degree Celsius. Now this is 0 degree Celsius ice. Now, to increase this temperature from minus 20 to 0, we have to supply heat and that heat is specific heat. Now, we have to convert that ice into the water, it is also at 0 degree Celsius. Water is at 0 degree Celsius. Means at that time we have to supply heat to that, and at that time that heat is called as latent heat of fusion. Means at 0 degree Celsius ice that gets converted into the water and phase is changed but temperature remains constant, and that heat is called as latent heat of fusion. Now we have to increase the temperature of this water up to 100 degree Celsius. Now 0 degree Celsius, that is the melting point, and 100 degree Celsius, that is the boiling point. Again the water is at 100 degree Celsius water, and for that purpose we supply heat that is nothing but specific heat. Now we have to convert this water into vapor, and phase is changed at 100 degree Celsius from water to vapor, and that heat is called as latent heat of vaporization. And again we have to increase the temperature from 100 to 120 degree Celsius. At that time heat required for that is the specific heat. Understood? Means to increase the temperature, heat required is called as specific heat, and to change the phase but temperature remains constant, the heat required, that is called as latent heat. To convert the ice into water, means solid into liquid at its melting point, that is called as latent heat of fusion. Now to increase the temperature of this water from 0 degree to 100 degree, we supply heat, that heat is specific heat. Again we have to convert the water into vapor at a 0 degree Celsius, means at its boiling point, that heat is called as latent heat of vaporization. Means water, that is liquid phase, and vapor, that is gaseous phase, and 100 degree Celsius, that is a boiling point, and therefore this is the phase change, and at that time this heat is called as latent heat of vaporization. Again we have to increase the temperature of this vapor from 100 degree Celsius to 120 degree Celsius. At that time we have to supply heat, and that heat is called as specific heat. In this manner we can explain that specific heat is used to rise the temperature and latent heat is used to change the state of that substance but at constant temperature. And in this manner we can explain the concept of specific heat capacity or specific heat and latent heat. I hope all of you understood this concept very well. Okay. Now the latent heat of what is the latent heat of fusion for water? That is latent heat of fusion for water, that is 3.33 into 10 raised to 5 joule per kilogram, and latent heat of vaporization for water, that is 22.6 into 10 raised to 5 joule per kilogram. This is the latent heat of fusion for water, and this is the latent heat of vaporization for the water. Okay, and from this we can say that this 1 joule heat means to convert the ice into the water or to melt the ice into the water at a 0 degree Celsius, the heat required, that is 3.33 into 10 raised to 5 joule. And the latent heat of vaporization for water, that is 22.6 into 10 raised to 5, means it is the heat 22.6 into 10 raised to 5 joule, that heat is required to convert the water into vapor at 100 degree Celsius. And this is the meaning of latent heat of fusion and latent heat of vaporization for water. Understood? And in this manner we can explain the article specific heat and latent heat. Understood? Okay. Now we will study the concept of thermal conductivity. Thermal conductivity. Thermal conductivity of solid. What is thermal conductivity? Thermal conductivity is a measure of ability of a solid to conduct heat flow through it. म्हणजे एखादा सॉलिड किती हीट वाहून नेऊ शकतो, त्याची हीट वाहून नेण्याची क्षमता किती आहे ते आपण मोजू शकतो. कशाच्या साहाय्याने? त्याच्या थर्मल कंडक्टिव्हिटीच्या साहाय्याने. म्हणजे जर एखादा पदार्थ त्याची थर्मल कंडक्टर चांगल्या प्रकारे हीट वाहून नेत असेल तर त्याची थर्मल कंडक्टिव्हिटी हाय असते, आणि तो जर वाहून नेत नसेल म्हणजे तो बॅड कंडक्टर असेल तर त्याची थर्मल कंडक्टिव्हिटी पुअर असते किंवा लो असते. नाउ टू स्टडी द कन्सेप्ट ऑफ थर्मल कंडक्टिव्हिटी, कन्सिडर ए steam chamber. This is a steam chamber, and in that steam chamber a steam is enter through one end and it leaves through another end, and a metal rod is here, a iron rod, that is nothing but a metal rod, and 4 holes are there, and a thermometer is inserted in that rod, and a mercury drop is inserted here for proper thermal contact, and this is the thermometer T1, this is thermometer T2, this is thermometer T3, and this is thermometer T4. When steam is flowing through this steam chamber, due to the conduction, this rod that gets heated, and temperature of this thermometer T1 is greater than temperature of this thermometer T2, it is greater than thermometer T3, and temperature of this thermometer T3 that is greater than T4. After some time this material is in steady state, means when this 4 temperature shows constant temperature, but T1 is greater than T2 and T2 is greater than T3 and T3 is greater than T4. At that time we can say that the material is in steady state. Now suppose this distance, that is the x distance, then the temperature difference T1 minus T4, that is the temperature distance in distance x, that is called as temperature gradient. We have to study the term, that is temperature gradient. Temperature gradient is defined as, temperature gradient is defined as rate of change of temperature with distance when material is in steady state, and this is called as the temperature gradient. Okay, I repeat, temperature gradient is defined as rate of change of temperature or change in temperature with distance when material is in steady state. Now to study the thermal conductivity, we have to consider a slab. This is a slab, glass slab. And consider these 2 parallel faces, and this parallel face, first parallel face, it is having temperature T1, and this face it is having temperature T2, and these 2 faces they are separated by distance x. Okay, now in this case the heat flowing through that slab, that is nothing but this heat flowing, it is directly proportional to the area of cross section. Suppose A is the area of cross section, then it is that heat flowing through this glass slab, it is also the directly proportional to the time, then it is also directly proportional to the temperature difference. T1 minus T2 is the temperature difference, because T1 that should be greater than T2, and that heat flowing through that slab that is inversely proportional to its distance. Then combining all these factors, we can write Q that is equal to, Q is proportional to A divided by A into T into T1 minus T2 divided by X. Now to remove this proportionality sign, we have to put constant, and that constant is small k, and this small k is called as coefficient of thermal conductivity. Coefficient of thermal conductivity, and therefore A into T into T1 minus T2 upon X. Rearranging this equation, we can write formula for coefficient of thermal conductivity, K that is equal to, now this Q by T, then A into T1 minus T2 divided by X, and this T1 minus T2 by X, that is nothing but temperature gradient. This is the temperature gradient, rate of change of temperature or change in temperature per unit distance when material is in steady state. This is the change in temperature in distance x, and therefore it is called as temperature gradient when material is in steady state. Understood? Now from this formula we can define the coefficient of thermal conductivity. Coefficient of thermal conductivity of a solid is defined as the heat flow. Q is the heat flow per unit time, because Q is heat flowing in time t, means the heat flow per unit time, per unit area, per unit temperature gradient when, बघा heat कशी flow होते, when heat flow is at right angle, when heat flow is at right angles to the faces of a thin parallel sided slab of material. बघा हे दोन्ही त्या जो काही मटेरियलचा स्लॅब आहे, सॉलिडचा स्लॅब आहे, त्याच्या पॅरलल प्लेसला तुमची हीट कशी आहे, राईट अँगल्स. अंडरस्टूड? अँड देअरफॉर दिस इज द डेफिनेशन ऑफ कोएफिशिएंट ऑफ थर्मल कंडक्टिव्हिटी. नाउ वी हॅव टू state its SI unit. Then what is the SI unit? By rearranging this equation, we can write K that is equal to Q into X divided by, or if you kept here, you can also write the SI unit. The SI unit of heat, that is joule. Then SI unit of time, that is second. SI unit of area is meter square. SI unit of temperature degree Celsius, and this distance that is distance is measured in meter. Now this meter and this meter that gets cancelled, and SI unit is joule per second meter into degree Celsius, or joule per second meter into degree Kelvin. But we know that joule per second, that is watt, and therefore one another unit, that is watt per meter degree Celsius, or watt per meter degree Kelvin. Means these are the 4 SI unit to measure the thermal conductivity of a solid. Now we have to obtain its dimensions. Okay, dimensions. Then we know that dimensions of K, that is dimensions of Q, it is a form of energy, that is nothing but L raised to 2, M raised to 1, T raised to minus 2. Then the time T raised to 1, then this L raised to 1, L raised to 2 and L raised to 1, that remain L raised to 1, and the Kelvin raised to 1, and total dimension, that is nothing but L raised to 1, M raised to 1, T raised to this minus 3, and Kelvin raised to minus 1. That is the dimension of the coefficient of thermal conductivity. These all 4 are its SI unit, and this is the dimension of a thermal conductivity. Now, okay, now we have to find the derivation for P conduction. P conduction, that is nothing but the time rate at which heat is flow, means that is nothing but the Q by T. And rearranging this equation, value for Q by T, that is nothing but, now we can write this equation in this manner. K, that is equal to Q into X divided by T into A into T1 minus T2. And therefore, the Q by T, this Q by T, that is nothing but Ka T1 minus T2 divided by X. This is the P conduction. This is the derivation for P conduction, that is nothing but P conduction means time rate at which heat is flow. किती वेळात किती हीट वाहून गेली, आणि त्यालाच आपण म्हणतो दॅट इज नथिंग बट वर्क पर युनिट टाइम, and that is the power, P conduction. The time rate at which heat flow, that is P conduction, and the derivation for or the formula for P conduction, that is equal to K into A into T1 minus T2 by X. Now we have to study the one more concept, that is thermal resistor. Thermal resistor. Thermal resistor. Thermal resistor. In case of a electric current, when suppose this is AB is the conductor and V is the potential difference and I is the current flowing through this conductor, then we know that the V, that is equal to IR, V is the potential difference, I is the current flowing through that conductor, and R is the resistance, and therefore electrical resistance, this is electrical resistance, that is nothing but the potential difference divided by current, and current, that is nothing but rate of flow of charge, and this is the formula to calculate the electrical resistance. म्हणजे जेव्हा करंट वाहून जातो त्याला अपोज जो करतो तो असतो इलेक्ट्रिकल रेजिस्टन्स. मग जेव्हा हीट वाहून जाते तेव्हा त्याला अपोज करणारा जो फॅक्टर असतो त्याला म्हणायचं थर्मल रेजिस्टन्स, आणि ही हीट जेव्हा इथं वाहून जाणार आहे तेव्हा त्याला अपोज करणारा फॅक्टर तो असणार आहे तो थर्मल रेजिस्टन्स. आणि तो कसा काढणार तर आपल्याला माहिती आहे दोन पॅरलल फेसेसमध्ये टेम्परेचर डिफरन्स आहे T1 आणि T2, आणि म्हणून T1 minus T2 divided by the time rate at which heat flow, that is nothing but Q by T, and that is the formula for thermal resistor, and T1 minus T2 divided by P conduction. We know that Q by T, that is nothing but P conduction, and P conduction, that is equal to, means we have to rearrange this equation. Therefore, the T1 minus T2 divided by this P conduction, if we rearrange this formula at that time, that becomes X by Ka. X by Ka. X by Ka, where X is the distance between two faces, parallel faces, K is coefficient of thermal conductivity, and A is the area. Understood? And in this manner we can obtain the derivation for the thermal conductivity, thermal resistor of in case of this thermal conductivity. Now its dimension, if you obtain the dimension, then you will get the dimension of X, that is L raised to 1, that is the distance. Now dimension of thermal conductivity, just now we obtained that L raised to 1, M raised to 1, T raised to minus 3 and K raised to minus 1, and also the dimension of area, that is L raised to 2. Now it becomes L total L raised to 3, and L raised to 3, that becomes 1 minus 3, that is nothing but L raised to minus 2, then M raised to minus 1, then T raised to 3, and k raised to 1. That is the dimension for the thermal resistance. Okay, and this is the dimension for L raised to -2, m raised to -1, t raised to 3 and k raised to 1. That is the dimensions to calculate the thermal resistor. Okay. Now last point, that is what are the applications of thermal conductivity. Okay, applications of thermal conductivity. What are the applications? In your book, 3 applications are there. First application, the cooking materials. They are having the handles of a wood or ebonite, because the cooking material म्हणजे कुकर जे काही कुकिंग मटेरियल असतं तर ते मेटलचं बनलेलं असतं, पण त्याचे हँडल जे काही आहेत ते लाकडाचे किंवा एबोनाइटचे बनलेले असतात. कारण जेव्हा आपण त्याला हीट सप्लाय करतो तर मेटल गरम होतं आणि जर ते हँडल मेटलचीच असते तर आपल्याला चटका बसला असता. आणि म्हणून वूड आणि एबोनाइट दॅट इज दी बॅड कंडक्टर ऑफ थर्मल कंडक्टिव्हिटी, आणि म्हणून ते कुकर त्याच्या ज्या दांड्या आहेत त्या एबोनाइटच्या बनलेल्या असतात आणि म्हणून आपण जेव्हा त्याला हातात धरतो तर आपल्याला चटका बसत नाही. हे ॲप्लिकेशन आहे, पहिलं ॲप्लिकेशन कशाचं तर थर्मल कंडक्टिव्हिटीचं. अंडरस्टूड. देन सेकंड ॲप्लिकेशन, जेव्हा कोल्ड स्टोरेज असतं तर त्या कोल्ड स्टोरेजमध्ये जे कोल्ड स्टोरेज बांधलेलं असतं ते थिक ब्रिक्सचं जाड अशा विटांचं बांधलेलं असतं, जेणेकरून बाहेरची हीट कंडक्शनद्वारे आतमध्ये येऊ नये आणि आतला पदार्थ गरम होऊ नये. त्या कोल्ड स्टोरेज मोठ्या मोठ्या प्रमाणात जेव्हा चिलिंग प्लांट असतो तिथं कोल्ड स्टोरेज बांधलेले असतात, त्याच्या भिंती ह्या अशा थिक अशा विटांच्या बांधलेल्या असतात आणि त्याच्यामुळं आतले पदार्थ हे गरम होऊ नये, थंडच राहावेत म्हणून अशा जाडजाड विटांच्या त्या भिंती बांधलेल्या असतात. आणि बऱ्याचदा त्या ज्या विटा आहेत त्या अशा पोकळ विटांच्या हॉलो ब्रिक्स आर देअर. कारण इथं एअर जो काही आहे आतमध्ये जर एअर असेल तर एअर इज ऑल्सो ए पुअर कंडक्टर ऑफ थर्मल कंडक्टिव्हिटी, आणि त्याने सुद्धा त्या जर पोकळ विटांनी त्या जाडजाड भिंती बांधल्या तरी सुद्धा आतमध्ये हीट कंडक्शनद्वारे येत नाही आणि त्या कोल्ड स्टोरेजमधले पदार्थ बराच काळापर्यंत हे थंड राहू शकतात. आणि तिसरं ॲप्लिकेशन सांगितलं, ज्यावेळेस बर्फाचा असा मोठा स्लॅब असतो तर तो खूप वेळ जर ठेवायचा असेल तर तो आपण त्याला गनी बॅगमध्ये ठेवतो, म्हणजे आपले जे गोणे असतात त्याच्यामध्ये ठेवतात. कारण गनी बॅग दॅट इज दी पुअर कंडक्टर ऑफ ए हीट, आणि त्याच्यामध्ये ठेवल्यामुळं ते बराच वेळ बर्फ वितळत नाही, तो तसाच राहतो. गनी बॅग दॅट इज दी पुअर कंडक्टर ऑफ थर्मल कंडक्टिव्हिटी, आणि म्हणून त्या गनी बॅगमध्ये बर्फ हा ठेवला जातो. बऱ्याचदा आपण पाहतो की आईस्क्रीमच्या दुकान असेल तर त्याच्या पुढे जर बर्फाचा स्लॅब असेल तर तो असा गोण्यांमध्ये गुंडाळून ठेवलेला असतो की बराच वेळ तो वितळत नाही, तो तसाच राहतो. अँड दॅट आर दी 3 ॲप्लिकेशन्स ऑफ ए थर्मल कंडक्टिव्हिटी. ह्या अशा पद्धतीने मी वन शॉटच्या दुसऱ्या पार्टमध्ये हा चॅप्टर खूप मोठा आहे आणि तो बराचसा कव्हर करण्याचा प्रयत्न केलेला आहे. मला खात्री आहे की हे सगळ्या कन्सेप्ट आपल्याला छान समजल्या असतील. जर तुम्हाला हा व्हिडिओ आवडला तर त्याला लाईक करा, आपल्या मित्रांबरोबर जरूर शेअर करा आणि चॅनलला सबस्क्राईब करायला विसरू नका आणि परत घंटीचं बटन दाबायला सुद्धा विसरू नका. व्हिडिओ पूर्ण पाहिल्याबद्दल धन्यवाद. थँक्यू वन्स अगेन.